Dr. Rajkumar Devani, and you're watching the second part of my video series, The Way I See It. Let's begin. In the first part, we discussed evolution, the basic theories of evolution. Let's move on to another interesting concept, which we have termed as interactivism. And it is also the title of today's discussion, as a missing piece of evolutionary puzzle, interactivism. My co-author with me is Mrs. Nirmala. The second part, a brief view on the highlights of this discussion today. Now, there are several new developments in the areas of genetics, evolution, mutation, inheritance, etc. And as we discussed in the first part, nature shapes itself through continuous interactions between organisms and their environment, which we call as interactivism. This is the main theme of this discussion, as the nature is shaped by the continuous interaction between organisms and their environment. It allows us to revisit the theories with new dimensions, such as we did it in the last video. We discussed Lamarck's theory in the light of interactivism and the modern theories, and we saw that we have in fact a lot of examples that relate to Lamarck's theory. It is now necessary to complete the evolutionary jigsaw puzzle by adding the missing element of interactivism. Basically, there has been a lot of debate on evolutionary theories and evolution, and there are certain things that are under question, and the other parts that are being continuously discussed, and new theories are being presented. But the thing is that no single theory completely explains the evolutionary phenomenon. And because, as we discussed in the previous discussion, that our traditional research methodology does not apply very comfortably onto biological research, and there were reasons that we discussed in the previous discussion or previous video. So we move on to further on this topic with the new idea that we have. So this discussion may provide us with clues leading to a better understanding of many of our health problems, linking them with their probable causes. This is the most important part, that when we have discussed evolution and we have discussed the evolutionary mechanisms, then humans are also bound by the same rules as applied in the nature, because we are also part of the natural machinery. Therefore, the health problems or issues that we face today these days, like heart attack, diabetes, and psychiatric problems, these can be better understood when we link them to the evolutionary mechanism. Let's move on. Okay, talking about I also included a similar slide in the previous video, in which we discussed about nature's capability and nature's designs and nature's state-of-the-art mechanisms. Here we also present two of natural mechanisms, just as an example how nature works, and these are just I would say a refresher examples to highlight some of the astonishing features of nature. First, we discuss the blood pH regulation, which is also remarkable, and the biological and inorganic components in the blood. They keep the blood pH regulated between 7.35, very narrow range, 7.35 and 7.45, and astonishingly, all the physiological functions of the human body and all the biochemistry works within this narrow range. And you may include anabolism, catabolism, all the different reactions, the energy production, energy consumption, and the reproductive system, every system, and the the transfer of the gases, respiration, all of the system works within this narrow pH range, this physiological range. This is very astonishing feature of when we talk about the human developed systems, we need specific temperature and pressure requirements to carry out a lot of our reactions that we do in the laboratories and the industries. But what happens that they are not eco-friendly, and we end up developing several chemicals that are not compatible with our environment, and leading to environmental pollution, which is contrary to what natural systems do. So the second example is the regulation of blood glucose. The blood glucose also remains in a very narrow range. The fasting range is 100 milligram per deciliter, and the random blood glucose range is up to 150 milligrams per deciliter. So that's also a narrow range, and if this range is exceeded, then many of the body organs are disrupted. The functions of many of the body organs are disrupted, and on long term, if it is kept in that way for a long time, then those organs are permanently damaged. So this is the case in when a person has diabetes. So I'm just saying that I'm just elaborating and shedding some light on the natural mechanisms that nature has a feedback mechanism of maintaining its systems, and this same feedback mechanism system is if it apply on the micro level, then why not at macro level, and that's what we call as interactivism. This is another astonishing example of nature's natural mechanisms, how the species have originated, and how they have specialized in functions that help them survive in the environment. Now, it's an example of camouflage. We will just see this is the seabed, and you can see several structures lying on the seabed, and you cannot distinguish one thing from the other, except for I think some sea animal lying on the floor. Okay, now if we I change the picture. Now you can see that an octopus is emerging from the center. It was camouflaged in the previous picture. It is camouflaged completely. Now this is the property. This is the property of the octopus, that it can hide itself in the environment by changing the color of its body. So now it's slowly emerging from that background, and it has changed its color. Now the octopus can use this mechanism to hide itself in the environment and to catch its prey. When it's threatened, it can also use it as a defense mechanism. And we also see in the same mechanism of camouflage, and many of the land organisms like chameleon or cricket, they also use the same kind of mechanism. So this again is another example of the remarkable capabilities of nature that has been developed through the evolutionary time scale, which is the focus of this talk. Okay, now we come to the idea. Actually, interactivism is not a very new development. In fact, it is the overall summary of the recent developments that we just discussed in the previous slide. Now, what we have in interactivism states that the modification of life is tailored by continuous interaction with the environment, and the frequency of which also has a significant impact on 2 points. The first thing is that the organisms are in continuous interaction with their environment, and when we say environment means that the other living organisms are also affecting the organism in focus. So they constitute the environment. It means the environment of an organism comprised of living and both living and non-living organisms, and the plants as well. So this all is live. The whole system is live, and it impacts each other, and this the frequency, the impact frequency determines how changes occur in the organism. If it is having difficulty in survival, then changes are more frequent. It starts to adopt ways to tackle the problem, and it's a two-way relationship. I've tried to explain it with a simple picture. We see organism here and environment here, and we see the impact of organism on the environment is outward impact, and the other is inward impact. So both of them comprise the interactivism. And there's another example of ripples in water. What happens when we add a drop of water in stagnant water? What happens? Ripples are formed, and they move away from the center of the circle, and then when they are reverted back from the edges, they come back again to the center of the circle. This process keeps on going until the ripples are settled and the water is stagnant again. What happens that the natural systems are also they also move in a similar fashion, and the stimuli from the environment trigger uh, the the mechanism of change in the organism, and it uh, initiates the process of change in the organism. Then the organism starts to adapt to the environment, and this process keeps on going from one organism to the environment, then environment to the organism, and then it stops or it slows down at a moment when the organism is compatible, is comfortable in the environment and can survive. So let's move on to the other slide. Acha, now we talk about mechanisms promoting change. Now Sir Charles Darwin suggested that the major uh, the major driver of change is mutation, and uh, mutation is fortified and established when natural selection goes on. But in nature, we see that the major mechanism of change is phenotypic variation and adaptive changes, which are need based. And we also see that now non-genetic inheritance has come into play. It has been discovered that non-genetic inheritance also takes place, and this inheritance is slowly through a mechanism transferred to the genetic codes, and it becomes part of the genetic the genes of the organism. But it is a slow process. It means adaptation is not very quick, and it depends on the demand of survival needs of the organism or animal. So this is how changes are sustained, and this is the modern view. How and the circle sizes here in the picture, they depict the frequency of that. So mutation was in earlier theories, mutation was the key role player, but we see that mutation are non-directional, and rather they depend on a proportional basis, and they have a probability of occurring. Okay, now this is an we call it an inward impact, the impact of environment on the species. We see the type of, there's just some examples to show how the interaction is it occurs. First, we see the interaction of temperature. When we talk about bacteria, they form spores to avoid harsh temperatures, and when the temperatures are favorable, the physiological conditions are favorable, then they come out of the spores and reproduce and live normally. And similarly, hair fall, or you say there are some animals that in the cooler regions where the winters are harsh, they grow hair in the winter season, and the hairs fall and they're lost in the summer season. So that is also interaction between environment and species. Then we see the skin darkening of skin pigmentation of organisms due to sunlight exposure, overexposure to sunlight. and in humans also the melanin pigment is increased when the skin is exposed to sunlight. And we've just seen an example of the octopus that environmental threat could lead to camouflage mechanism in many of the organisms that have developed it over the evolutionary timescale. Then parenting, we talk about parenting in the environment or from the parents, they confer learning in the offsprings. This is also an interactive mechanism. And then symbiosis, which leads to developmental plasticity and variation in developmental properties that lead to phenotypic or adaptive evolution. Water scarcity in the area leads to migration of animals to better places where water is present in abundance. Then we talk about environmental pollution, which is caused by, which leads to uh, diseases like cancer in organisms, and environmental pollution the um, is connected with anthropological activities, and it's connected with human activities mostly. So these are the environmental impacts on species. Now we look at some examples of the other part. That is the impact of species on the environment. Well, we see animal feces as plant fertilizer, which promote vegetative growth and the food chains. Completion of food chains. They form the symbiosis or symbiotic relationships, like commensalism and parasitism. And changes in environmental pollution, they work as a feedback population control in some examples. So just as if we take an example of the curd forming lactobacilli, they decrease the pH, they make it acidic, and that environment, when it's when the pH drops to a certain level, those organisms or bacteria are destroyed by themselves. So it works, the changes in pH, it works as a population control mechanism in this example. So again, it's a part of the interactivism. Then we have niche construction, which leads to favored selection, and then many animals and birds eat fruits, and they propagate the seeds, which promotes the vegetative diversity. So we see in all these examples that the organisms and the environment, they work in close relationship with each other, and they groom each other. This is the basic concept. Predation leads to population control mechanism, as we see in savannas and different forests. Pollinating agents are very important in many different parts of the world, where we need to in agricultural lands, when we want to carry out pollination, we use the pollinating agents. Especially, I've seen a video of the honeybees. Honeybees are used as very effective means of cross pollination. So again, interactivism, all the examples of interactivism, we can see that there are close relation between species and environment, and this is what drives the evolutionary machinery. And if it drives the evolutionary machinery, the machinery is still continuing to work. Now, some of my colleagues asked, and this is an old question, not new, but we are reconsidering it here now. Why the monkeys have stopped converting into humans? I mean, if you say that evolution is there and some monkeys converted into humans, what went wrong with the other monkeys? And why are they there when they have been converted to humans? Very good question. Uh, we To answer the question, we consider the example of horseshoe crab, which is considered as a living fossil and also discussed in Darwin's literature. Um the horseshoe stayed the same, and it survived around more than 200 million years, and it stayed the same. And it's found some coastal areas. And what went wrong with it? Why did it not participate in the evolutionary system? Uh, well, among the key drivers of change are survival and environmental changes. So, environmental changes, it means the stimuli is environmental change. when the environment changes in some way, then the organisms tries to survive through that, and it acquires changes. So this is the mechanism. We have just seen the examples and how it works. A constant environment could make changes extremely slow. It means that species that feel and experience constant environment are less liable to changes, and the changes are very slow, and either we don't see it or they don't happen at all. So the monkeys that stay on the trees, they love the way they are. So there are no environmental stimuli that stimulate changes in them. So we don't see very drastic changes in them, and they are living, and adaptability is almost constant. Uh, the fossil fuels are found and can be found in deep sea life, which is untouched, mostly, which have been untouched, but now you can't say, as the sea pollution has also on a greater rise. So the deep sea life, or life on far off islands, we can find species that have not been affected by evolutionary time scale. Emergence, okay, change and reproduction could be associated traits of not only the life forms but biomolecules also. Now, when we see that in case of corona, we see that many more virulent strains of corona were discovered later on. So we see the evolutionary path is also taken by those non-living things. The viruses can be termed as half living and half dead because they acquire some of the characteristics of living, just like they reproduce. And when they come in contact with this living cell, they start functioning and working. So the viruses also, but even the virulence or changes in the virus are directed. We don't see any less virulent uh, strains of virus that we can see that that can easily survive, but we don't find them. It means that the evolutionary phenomena, the evolutionary mechanism is directive, and it is directed in a way that benefits either the environment or the organism itself. So it's directive, and it is not random that we can say that it just occurs because of mutation. Okay, now the consequence of interest. So if we have discussed all of this new idea and the latest research, but where is it going? What is the purpose? Now, if you believe in evolutionary mechanism, and we should, that we have all the evidence that supports it, all, and it explains the diversity on this planet, and the evolutionary time scale is also confirmed through many advanced techniques. So, what are the consequences? That we may see in the future that mothers may lose the capability of giving natural birth as a long-term consequence of C-section surgeries. Now, C-section surgeries are a very important technology to save babies, and both babies and mothers. But we see that, on the contrary, it misses the complete part of natural birth, and if this mechanism is not experienced by mothers, then obviously in the next generations the capability will be gradually lost, and it is observed by the Briggs in 2016, published by Briggs in 2016 UK. So these can be the long-term consequences. And another consequence could be a quick development of children at a comparatively early age and early puberty. We are the It's common observation, and Wallace, Downing, and Ashton have reported in 2006 that it's happening. And in certain parts of the world, the average human age has also been affected by the lifestyle and the living um, of humans. So this evolutionary mechanism is also affecting us. But the question is, why is it going on the negative side? It means that the environment we are living in is not supportive to and it's not compatible with natural systems. That's why we are experiencing more negative impacts. Now, other thing is that the increasing frequency of diabetic disorders. Now, whenever you go to a doctor and you report diabetes, you would say that, oh, your grandmother had it, or your great grandmother had it, maternal side, paternal side, and they would always link it to the genetic code on the genetic mechanism. But more recently, scientists have linked it with social and mental pressures. Diabetes is also been linked with social and mental pressures, and with lack of physical activities and excessive use of processed food. So all these unhealthy habits which deviate from the natural processes, they lead to these diseases, and it means the evolution is now working on the side we are pushing it. So this is a way of shedding some light how we can improve ourselves and the nature in which we are living, and both need to be improved as both are connected. Last one is making changes in natural systems easier, but their correction is way too difficult, especially when staying in ethical boundaries, which is necessary. Well, this is a very important point. When we play with the natural system, when we modify a natural system, when we modify the environment, it's easy. But the nature has its own way of correcting the problems, the disorders, the human and animal issues, and it excludes the defected genes by its own mechanisms, which is somehow which is sometimes unethical. But now, when we have made so many changes, we have to sit down, we discuss, and find ethical ways of doing the same thing what nature does. Summary and of all the this talk. Some is that the natural systems are complex, carefully developed over a very large time period. This is what gives nature the value it has, which we sometimes don't realize. We see plants in our garden, so we don't realize how long they have taken to take the shape they have now. And the fruits and the vegetables, how long they have changed and traveled to come to us in the state we have them. So we care about monuments, we care about constructions that have been made 5,000, 4,000, or 2,000 years ago. We don't care about with the same seriousness. We don't care about things or nature that have taken a very long time to develop. Now, this is the main theme of the talk. And if we don't care about those things, then the surrounding environment also affects us, and it's us affects us negatively. So the natural system is smart and interactive. Nature works through interactive mechanisms, and it is the reason why evolutionary mechanisms are also interactive, that we have discussed so far. And we have connected our discussion with the current human health problems. So we can, apart from apart from corrective medicines and corrective mechanisms, we introduce preventive mechanisms and preventive uh, mechanisms to treat our modern issues like heart attack, cancer, diabetes, and many of psychiatric issues. So, ladies and gentlemen, this paper or publication also available on the link. You can see it on the, below, and you can trace it by the author names or the title of this presentation as the missing piece of evolutionary positive interactivism. These are some references used in this discussion. The other references can be complete references can be found in the paper, the complete paper. And at the end, thank you all.